Hello everyone, and welcome to this training video. To begin, I would like to briefly introduce the focus of this training module. This session is part of the EnerCmed training program and serves as an introduction to nature-based solutions and their role in addressing two closely linked challenges in urban areas: the urban heat island effect and the sustainability of renewable energy communities. Across Mediterranean port hinterlands, climate pressures such as rising temperatures, heat waves, and extreme weather events increasingly affect urban life, energy demand, and infrastructure. At the same time, renewable energy communities are emerging as key instruments for a fair and decentralized energy transition. This training explores how nature-based solutions can act as a bridge between these two agendas, supporting both climate adaptation and energy resilience at the neighborhood level. Before going deeper into the technical concepts, it is important to briefly place this training within the EnerCmed project context. EnerCmed is an Interreg Euro-MED project that aims to promote the energy transition in port hinterlands through the development of renewable energy communities integrated with nature-based solutions. The underlying idea is that energy transition cannot be addressed in isolation. It must be combined with social inclusion, climate adaptation, and spatial planning. The project focuses on residential areas in port cities across Spain, Croatia, Greece, and Italy, areas that often face high environmental stress, social vulnerability, and limited access to affordable energy. EnerCmed supports these territories through training, capacity building, and technical assistance, working closely with municipalities, urban authorities, and local stakeholders. This training module provides an extended introduction to nature-based solutions and explains how strategically designed natural systems can respond to pressing urban and environmental challenges. A key focus is the urban heat island effect, one of the most critical climate-related stressors in densely built environments. The module explains how NBS mitigate UHI by increasing surface albedo, enhancing evapotranspiration, and expanding green and blue infrastructure. At the same time, the module explores how nature-based solutions can strengthen the long-term sustainability of renewable energy communities. By reducing cooling demand, improving local microclimates, and enhancing resilience to climate risks, NBS creates synergies between energy efficiency, climate adaptation, and community well-being. Throughout the training, we will refer to practical examples relevant to Mediterranean port hinterlands, showing how these solutions contribute to healthier, more livable, and more resilient neighborhoods. So, what exactly do we mean by nature-based solutions? Nature-based solutions are strategies inspired by natural systems that use plants, water, soil, and ecological processes to address urban challenges in a sustainable way. Rather than relying solely on technical or gray infrastructure, NBS work with nature to deliver multiple benefits at the same time. As shown in the diagram, we can broadly distinguish three main categories. First, vegetation-based solutions, such as street trees, green roofs, green walls, and urban parks. Second, urban design solutions, which integrate climate-responsive materials and layouts into the built environment. And third, water management solutions, including rain gardens, ponds, permeable surfaces, and stormwater retention landscapes. Together, these approaches not only reduce urban temperatures, but also improve environmental quality and everyday urban life. To understand why nature-based solutions are so important, we need to briefly introduce the urban heat island effect. Simply put, cities tend to be warmer than surrounding rural areas. This happens because urban surfaces such as asphalt, concrete, and building facades absorb and store heat during the day and release it slowly at night. As a result, temperatures in dense urban areas remain elevated, especially after sunset. For renewable energy communities, this is a critical issue. Higher urban temperatures directly translate into higher cooling demand in homes and buildings. This increases pressure on local energy systems and challenges the ability of RECs to meet demand in an efficient and equitable way. Let's now look more closely at the main drivers of the urban heat island effect. Dense infrastructure, including buildings and roads, traps and retains heat. At the same time, The lack of vegetation limits natural cooling processes such as shading and evapotranspiration. Increased energy use from air conditioning, vehicles, and industrial activities adds even more heat to the urban environment. These factors create a feedback loop. As temperatures rise, cooling demand increases. This can lead to higher energy bills, greater stress on energy systems, and reduced efficiency of renewable technologies, particularly photovoltaic systems, which perform less efficiently at high temperatures. From the perspective of renewable energy communities, the urban heat island effect has three major consequences. First, it increases energy demand, especially for cooling during summer months, placing additional pressure on local energy production and distribution. Second, it exacerbates energy poverty. Vulnerable households in rec areas may struggle to afford higher cooling costs, particularly in socially disadvantaged port hinterlands. And third, it reduces energy efficiency. High ambient temperatures lower the performance of photovoltaic systems, directly affecting renewable energy output. Addressing UHI is therefore not just an environmental issue, but a social and energy justice issue as well. Let's now turn to solutions, starting with vegetation-based, nature-based solutions. Vegetation is one of the most effective tools for cooling urban areas. Trees provide shade and cool the air through evapotranspiration, a natural process where plants release moisture into the atmosphere. Green roofs and green walls reduce heat absorption, insulate buildings, and lower indoor temperatures. Urban forests, street trees, parks, and green corridors can create large-scale cooling zones, reducing surface and air temperatures across entire neighborhoods. For renewable energy communities, these cooling effects translate into lower cooling demand, improved energy efficiency, and better performance of photovoltaic systems. The energy-related benefits of vegetation-based solutions are particularly important for RECs. Cooler surroundings lead to reduced reliance on air conditioning, lowering electricity demand during peak periods. This helps stabilize local energy systems and reduces energy costs for residents. At the same time, lower ambient temperatures improve the performance of PV systems, increasing renewable energy generation without additional infrastructure. In this way, vegetation-based NBS directly support both the environmental and economic sustainability of renewable energy communities. Finally, we move to urban design solutions. Urban design solutions focus on reshaping the built environment to reduce heat absorption and enhance natural cooling. Examples include cool pavements made of reflective materials, architectural shading structures such as pergolas and awnings, and ventilation corridors that allow air to circulate through urban areas. Optimizing building orientation can also significantly reduce heat gain from direct sunlight, lowering the need for artificial cooling. However, it is important to note that urban design interventions can be more complex to implement. They often require higher investment, long-term planning, and coordination with private property owners and local authorities. Despite these challenges, when combined with vegetation and water-based solutions, urban design measures play a crucial role in creating climate-resilient and energy-efficient rec neighborhoods. Now that we have introduced urban design solutions, let's focus more specifically on their benefits. Urban design interventions contribute significantly to overall urban livability. By reducing heat stress in public and private spaces, they make rec neighborhoods more comfortable, safer, and more attractive for everyday use, especially during extreme heat events. From an energy perspective, lowering ambient temperatures directly reduces cooling demand in buildings. This means less electricity consumption for air conditioning, fewer peak loads, and lower operational stress on renewable energy communities. At the same time, by reducing urban temperatures, these solutions improve the efficiency of renewable energy systems, particularly photovoltaic panels, whose performance declines as temperatures rise. In this way, urban design solutions support both climate resilience and energy efficiency, reinforcing the sustainability of RECs at the neighborhood scale. We now move to the third major category of nature-based solutions, water-based solutions. Water-based solutions use urban water elements, such as wetlands, fountains, ponds, rain gardens, bioswales, and permeable pavements, to naturally cool cities through evaporation and evapotranspiration. Beyond cooling, these solutions play a critical role in managing stormwater. Instead of quickly channeling rainwater away through conventional drainage systems, water-based NBS retain, infiltrate, and slow down runoff. This is particularly important in Mediterranean cities, where intense rainfall events are becoming more frequent due to climate change. Water-based solutions therefore act as multifunctional systems, addressing heat, water management, and urban resilience simultaneously. The benefits of water-based solutions are closely linked to both energy and climate resilience. By lowering ambient temperatures, these solutions reduce cooling energy demand in surrounding buildings. Cooler microclimates translate into lower electricity consumption and reduced pressure on REC energy systems. At the same time, water-based solutions enhance overall energy efficiency by reducing local heat accumulation, creating more stable operating conditions for renewable energy technologies. Importantly, these solutions also improve resilience to extreme weather. By managing stormwater more effectively, they help protect buildings, public spaces, and energy infrastructure from flooding and heat-related damage. For renewable energy communities, this means greater reliability, reduced risks, and stronger long-term sustainability. At this point, we can clearly see why nature-based solutions are critical for the sustainability of renewable energy communities. NBS directly address the environmental and social stresses that affect REC performance and acceptance. Urban heat, flooding, and climate extremes increase energy demand and place significant stress on local energy systems. High temperatures reduce renewable energy efficiency, especially for photovoltaic systems, while climate risks threaten infrastructure, social cohesion, and a long-term viability of community-based energy initiatives. By mitigating these risks, nature-based solutions create the conditions in which RECs can function not only as energy producers, but as resilient, community-centered systems embedded in their local environment. This slide summarizes how nature-based solutions strengthen renewable energy communities across three key dimensions. First, climate regulation. Urban greening and blue infrastructure reduce ambient temperatures, lowering cooling demand and peak energy loads. This also helps reduce energy poverty risks, particularly for vulnerable households. Second, system efficiency and resilience. Lower temperatures improve photovoltaic efficiency and overall system reliability, while stormwater management protects energy infrastructure from extreme weather events. And third, social and territorial co-benefits. Nature-based solutions create shared spaces that enhance community engagement, ownership, and participation. This strengthens local acceptance and supports more inclusive governance of renewable energy communities. Nature-based solutions should be understood as multipliers of REC sustainability, not as add-ons. They transform renewable energy communities into multi-benefit systems that go beyond energy production. By increasing long-term climate resilience and reducing operational risks, NBS enhance the overall performance and durability of RECs. At the policy level, they align RECs with key European priorities, including the EU Green Deal, climate adaptation strategies, and nature-based solutions frameworks. Most importantly, NBS strengthen energy democracy. Through place-based and inclusive design, they reinforce the social foundations of renewable energy communities, turning them into integrated, climate-resilient neighborhoods rather than energy-only initiatives. To conclude, nature-based solutions offer a powerful and practical pathway for enhancing the sustainability of renewable energy communities. By addressing urban heat, reducing energy demand, improving renewable energy efficiency, and strengthening climate resilience, NBS connect environmental, social, and energy objectives at the neighborhood level. For Mediterranean port hinterlands in particular, integrating nature-based solutions into REC planning is not just beneficial. It is essential for ensuring long-term resilience, social inclusion, and energy justice. Thank you for taking part in this EnerCmed training session. For more information, additional resources, and practical examples, you can visit the EnerCmed knowledge sharing platform using the QR code provided. We look forward to continuing this learning journey together in the next training modules.